Now let's take a look at how to do this homework problem. So the question says a boat is sailing toward a cliff. So let's make a little diagram as we go. So we'll have some water, and I'm not going to draw pictures, just a diagram, so we'll just have this dot be our boat. Okay, it's sailing towards a cliff, so we'll have a cliff here. The cliff rises, in this case, 246 meters above the level of the water. So this height is 246 meters. That's not changing over time, so that's going to stay a fixed constant. We don't need to make it a variable. Okay, and if we were a person on the boat looking up at the cliff, then there would be an angle of elevation. We're going to call that theta. And then we also have the distance from the boat to the base of the cliff. We'll call that x. We do leave that as a variable because presumably the boat is moving, and so that distance can change over time. Okay, so as the boat approaches the cliff, this distance x will get smaller, and the angle theta will get larger as the person has to look up more steeply to see the top of the cliff. All right, first, find an equation for theta in terms of x. So if I look at this green triangle that we've sort of created, and I pop that out, oops, let's make that a little neater. The bottom base is x, and it's a right triangle, and the other leg of the triangle is 246 meters. And then we have this angle theta. Now, if I was trying to relate three sides of a triangle, I'd use the Pythagorean theorem. When we're relating sides and angles of a triangle together, especially if it's a right triangle, we use trig functions. So because the two sides that I have are opposite of theta and adjacent to theta, and I'm not involving the hypotenuse, I'm going to use the tangent function. So tangent theta equals 246 over x. So that gives me an equation that relates theta and x. It doesn't exactly answer my question, though, because it says find an equation for theta in terms of x, so we need to solve for theta. We want theta equals. So that's where I'm going to use the inverse function. So if I take the inverse tangent of both sides, the inverse tangent and the tangent function cancel each other out. That's the point of inverses, so we get theta. And on the other side, we get tangent inverse of 246 over x. Okay, so that's the answer to the first part of this question. We've created a function for theta in terms of x. The next part says to find the rate of change of theta with respect to x. That's a keyword that means derivative. Rate of change is what a derivative is, right? So this says find that when x is, in this case, 187 meters. So what we're doing is we're finding a derivative and plugging in an x value to find a derivative at a specific point. Okay, we've done this a lot in the past. In a geometric setting, we would call that slope. In this case, it's a rate of change of theta with respect to x. So let's go ahead and differentiate. So I'm going to differentiate theta equals inverse tangent of 246 over x. Okay, and I'm going to be a little bit careful about this. One of the things that is very important to note is that tangent inverse of x is not 1 over tangent x. Okay, even though, you know, if I wrote something like tangent squared x, that is indeed tangent of x squared. But when we write a -1, it's not tangent of x to the -1. Okay, that's just how our notation goes. It's inconsistent, it's bad, but that's what we have to deal with. So what might be helpful is thinking of anytime we have this inverse function, we could also write it as arctangent instead. So I'm just going to go ahead and write it as arctangent, not because I have to, but just to avoid confusion. And what I'm going to do on the inside is change this into 246x to the negative 1 power. That's the main reason why I'm rewriting this. Okay. All right. So now when I differentiate, on the left I'm going to have the derivative of theta with respect to x. And then I need to figure out what the derivative of arctangent is. And we don't need to solve this fresh every single time. By this point in the homework, you've probably already looked at a derivative of inverse tangent or arctangent. Okay, but we can also reference those as time goes on. So the derivative of arctangent of x is 1 over 1 plus x squared. So here I have an inside function, so I'm going to use the chain rule, where my outside function is arctangent of stuff. So I'm going to use this derivative formula, 1 over 1 plus x squared, except I don't plug in the x, I plug in the inside function, 246x to the negative 1. Okay, and then the chain rule says multiply by the derivative of the inside stuff. Okay, that inside stuff I can differentiate using the power rule. So I get 1 over 1 plus 246x to the negative 1 squared, and then I'm multiplying that by negative 246x to the negative 2. Okay, we can simplify that a tiny amount, but I'm not really going to spend any time cleaning that up. And the reason for that, I do want to rewrite this so that these negative powers are kind of gone, so that I don't make a mistake when I plug in. But I don't really need to simplify this expression because I'm going to plug in and just get a number anyway. Okay, so our goal here is to find the derivative of theta with respect to x when x is equal to 187. So what I can do is I can just plug that x value in. And then just evaluate the number that I get. Okay. Now, this isn't going to come out to like a nice, neat number like 3 or anything like that. So we're just going to plug it into our calculator. Okay. And so the number I get is negative 0.0025763,209. Okay. And the problem says round to 3 decimal places. What I want to do is look at it and does it say reasonable? And in particular, does the negative make sense? So if I think of this as rate of change, what I'm doing is saying as x gets bigger, or you could think of it as every time x gets 1 bigger, what happens to theta? Well, if x is getting bigger, the boat is getting further away, so that angle should be shrinking, right? So the negative makes sense. And it shouldn't be shrinking by very much, right? If this boat is already 187 meters away, 1 more meter isn't going to make a huge difference of the angle. Remember, this is also radians, not degrees. Okay, so it makes sense that I get a small negative number.